So this video is to use the basic quotient identity for tangent. The tangent of anything is sine of that thing over cosine of that thing, to get a formula for the tangent of the sum of two angles. And I'm going to leave it as an exercise and not derive tangent of a difference, because it's quite similar. So, okay, so I've got sine of the sum, and I just remember from the identities for the sine of a sum that it's the sine of the first cosine of the second plus cosine of the first sine of the second. Plus goes with plus with sine. And then on cosine, I've got cosine of the first. Here, why did I put parentheses in there? Sorry, I'm not putting parentheses anywhere else. Cosine of the first, cosine of the second. But then with cosine, the plus or minus is the opposite. So it was plus inside with, alpha plus beta. So it's going to be minus here. Sine of the first, sine of the second. Now this looks like a god-awful mess. And the kind of things that you have to resist doing are things like just simplifying and going, oh, sine beta, schwack. You can't do that because it's not a factor of both the top of the fraction and the bottom of the fraction. Sine of beta is just a factor of that term. There are no sine of betas over here. So the trick here is, and I have to call it a trick because if you don't remember what to do next, how are you going to be able to do it, and how do you remember what to do next? But what I'm going to do is I'm going to think of this as a complex fraction that I'm going to multiply top and bottom by cosine of alpha, cosine of beta. So cosine of alpha, cosine of beta. When this distributes to each of the terms in the top and each of the terms in the bottom, bunch of stuff happens, which is pretty cool. So when it hits this first guy, I get sine alpha cosine beta, which was what was there before, times 1 over cosine alpha cosine beta. Then it hits the next term, which had cosine alpha sine beta, times 1 over cosine alpha cosine beta. So that was the top of that big old fraction, and the similar thing happens in the bottom. You had cosine alpha, cosine beta, cosine alpha, cosine beta, minus, started with sine alpha sine beta, and multiply by 1 over cosine alpha cosine beta. And at first glance you're like, what the heck? Why would you go through all this mess? But then you go, oh, well, that's 1, and so's that, and so's that and that. So that's quite a lot of 1s. And then there's tangent alpha, and there's tangent beta, and there's tangent alpha times tangent beta. So wow. Okay, so this one here, that's just 1. So I've got, see if I can write it here and then write it again on the next page more clearly. But I've got tangent alpha plus tangent beta on the top of this, and then just 1 minus tangent alpha times tangent beta. So that was a god-awful mess. I will write it over here. So the tangent of the sum of two angles, after all that little bit of algebra, is tangent of the first plus tangent of the second. That's kind of cool right there, as if you can distribute the tangent in a way. But it's not quite that simple. You've then got 1 plus tangent of the first times tangent of the second. And so let me actually do an example of that. I mean, that's just a remarkable thing. So let's say I was trying to figure out what the heck is the tangent of 75 degrees. 75 is not a special angle. The only special angles we have in the first quadrant are 30, 45, 60. It's none of those. But it is the sum of those, a couple of those. So it's 75 is just 45 plus 30. So what I'm going to do is say, all right, okay, so that's tangent of 45, tangent of the first, plus tangent of 30, over 1 plus tangent of 45 times tangent of 30. And so, okay, what good is that for us? But all of these we know. Tangent of 45, that's the slope of the line that you go right in the middle, so that's 1. This whole guy is just 1, and it is over here as well. And tangent of 30 is the y-coordinate over the x-coordinate on this square root of 3 over 2 comma 1/2 ordered pair. So I'm sorry that's so small. Hopefully you're pretty good at special angles by this time. But tangent of 30 degrees is just 1/2 the y over square root of 3 over 2. So why divide by square root of 3 over 2 when you can multiply by 2 over square root of 3? Schwack, schwack. So that's just 1 over square root of 3. Or if you rationalize, square root of 3 over 3. So this guy's square root of 3 over 3, and this guy's also square root of 3 over 3. And, there's some cleaning up to do. But what we've got is 1 plus square root of 3 over 3 over 1 plus square root of 3 over 3. Now, wow. Something missing. Something missing. Aha! Never use your memory. Never use your memory. And so how did I know I'd screwed that up? So I went through and I went from this page, went over, remembered the plus on the bottom when it's really minus. But just now I said, wait, 1 plus square root of 3 over 3, 1 plus square root of 3 over 3. Well, that's same over same. That's just 1. That can't be. For a 75 degree angle, which is over here someplace, no way is that slope 1. So I realized my mistake, got a negative in there, which makes, let's just rewrite it over here, tangent of the sum of two angles is tangent of the first plus tangent of the second over 1 minus tangent of the first times tangent of the second, which when I put in the 75 becomes 1 plus square root of 3 over 3 over 1 minus square root of 3 over 3, which if you check your calculator on this guy and then carefully check your calculator on that one, they should come out the same.